So here's the general equation of a line. All right, so this is in standard form. Standard form is really the least useful form because our slope's not isolated. Right, so we would have to rewrite it to find out the slope or the y-intercept. So not as useful as point slope or slope-intercept form. So the graph of every linear equation where we have ax plus by plus c, where a and b are both are coefficients, and they can't both be 0 because otherwise we wouldn't have any variables at all. And c is a constant, equals 0 is a line, right? So conversely, every line is the graph of a linear equation. So every line can be written in standard form. This general form here can be written in slope-intercept form. It can be written in point-slope form. So if you have an equation and it is written in standard form and you want to graph it, you can do one of two things. So you only need 2 points to graph a line. You can A, find the x and y intercepts. And I'm going to put A rather than 1 because this isn't steps, this is an either or. So find the x and y intercepts and graph the points to graph the line. Or B, rewrite in a slope-intercept form. And then graph the y-intercept. And use the slope to get more points. Either is fine, whichever you prefer. Sometimes, well, both of these use the y-intercept, so if your y-intercept's not an integer value, you're going to have to deal with that. If your x or if your y-intercept's not an integer value, then it's probably easier to graph the x and y-intercepts. If your y-intercept is an integer value, but your x-intercept's not, then it's probably easier to graph the y-intercept and use the slope to get more points. Let's do the first let's use method A first, and then we can just take a look at method B as well. All right, so finding the x and y-intercepts. All right, so x-intercept, you're going to substitute 0 for y and solve for x. So that would be 2x minus 3 times 0 minus 12 equals 0. All right, so it's going to be 2x minus 12 equals 0. That means 2x is 12 and x is 6. I need a little bit more space. There goes my pen. Let's see if I can squeeze the x-intercept somewhere. Maybe if I move this down a little bit. All right. So we got the x-intercept. Let's find the y-intercept. So for the y-intercept, substitute 0 for x and solve for y. So 2 times 0 minus 3y minus 12 equals 0. Negative 3y equals 12. So y is negative 4. So we have 2 points, 6, 0, and 0, negative 4. We could graph those 2 points. Negative 4, 0, and then connect the 2 points to graph the line. Did I get a, there we go. Come on. There, I think that's as close as I'm going to get moving this line around. Okay, there, that looks pretty good. And we should put arrows because that is going to continue. All right, let's use method 2 as well, and so we can just compare. All right, so we'll rewrite it in the slope-intercept form. All right, so that we've got 2x minus 3y minus 12 equals 0. Let's subtract the 2x and add the 12 to both sides. So that's going to be negative 3y equals negative 2x plus 12, and divide by negative 3. So that would be y equals 2/3 x minus 4. So notice we would have the exact same y-intercept, right? 0, negative 4, so that's already graphed. Let's just check and see if the slope is correct. All right, so we have a slope of 2/3. That means our line is going to rise 2, and then the run will be 3. All right, so up 2 to the right 3, and that does indeed match our line. So we could have chosen either method, rewriting it in the slope-intercept form and using the slope to get more points, or just find the x and y intercepts and graphing those and connecting to graph the line. All right, so now I have some for you to try. All right, and I'll see you in the next video. Bye for now.